Hey class, guess what? Last lesson of chapter 16, our last lesson together ever. All right, lesson 4, we're dealing with zero and negative exponents now. So let's look at our key ideas and our properties here. If we have 0 as our exponent, any non-zero base with an exponent of 0 is always going to equal 1. But we just can't have 0 as the base. Again, it said any non-zero base. It'll always equal 1. So any number besides 0 is allowed to be the base. Like if I have 4 to the 0 power, automatically just equals 1. Any number with a power of 0 is always going to equal 1. So a can be any number, will always equal 1. The only number a cannot equal is 0. Because then that's undefined. Next key idea or property is, what if we have negative exponents? I will say this is when it gets a little tricky, but a negative exponent is just the reciprocal of its positive version. So a to the negative n is the reciprocal of a to the positive n. So think of what a reciprocal means. If I have 4 to the negative 2 power, now, I'm not just going to write that as 4 to the positive 2. I need its reciprocal. So if I asked you to take the reciprocal of 1/2, you would tell me the reciprocal is, right, you would flip it to 2 over 1, remember? So that's the same thing here. We're going to have to flip this power so that it's 1 over 4 squared. It becomes positive. It just now goes in the denominator. So it's the easiest way I can explain that. It's the reciprocal, we just flip it. So now for any base, if it has a negative power, to rewrite it as a positive, we just flip it. We put 1 and then put it in the denominator as its positive version. All right, let's do some examples here. Evaluating expressions. So I want to evaluate 3 to the negative 4th. Now remember, evaluating means to solve. Now, I have a negative power. I don't like negative powers. We want to make it positive. So we're going to rewrite it just like up here in its positive form, just as its reciprocal. So I'd have 3 to the positive 4th. Since it wants me to evaluate it, we're actually going to do 3 to the 4th. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 gives me 81. So that's my answer. Next, I have the same base. I'm noticing the same base. So when they have the same base and they're being multiplied, we just add our powers. Well, what does negative 4 and a positive 4 give you? 0. Any number raised to the power of 0 just equals 1. So we evaluated that. Our last one, I see quotient of powers, which means we subtract our powers. We're doing 6 minus 8, so it's okay to get a negative power now. So I have 2 to the negative 2, but I'm not done because I'm trying to evaluate it. I don't want a negative power, so let's rewrite it in its positive form. And now do 2 times 2, you get 1/4. That's it. All right, what I would like you to do is use those examples kind of as a model. And I actually have 6 down here, A through F. I want you to try, write them down, try to solve them. So pause the video and then press play when you are ready. We're going to go through them. All right, A, I see a negative power. Let's rewrite that as a positive. And now evaluate that. 4 squared gives us 16. Look at B, I see a negative power. Let's rewrite that. So I should have 1 and then negative 2 to the 5th. And now let's evaluate that. You're multiplying negative 2 together 5 times. When you do that, you get a negative 32. C, I see they have the same base. So, and we're doing product of powers, so add your powers. But a negative 8 and a positive 8 gives me 0. Remember, a number raised to the power of 0 always just equals 1. keep chugging along here. D, I see quotient of powers, so I'm going to subtract 5 minus 6. That gives me a negative 1. Let's rewrite that with a positive power. So this is just 1 to the negative third, or just negative 1/3. You don't have to write that power. Let me get rid of my parentheses. This is just our final answer. All right, this one, a little tricky. We're multiplying, and these are already in fraction form, which is fine. So when I'm multiplying, I'm going to be combining or adding these powers. So we know 1 times 1 is 1. Keep your base of 5. 7 times a negative 4 gives me a positive 3. Now I'll just do 5 times 5 times 5. You get 125. Last one, I'm going to combine my numerator. They're being multiplied, same base, so we add 5 plus a negative 3 gives me a positive 2. Now we have a quotient of powers, so we subtract our powers. 2 minus 2 is just 0. So 4 to the 0 power gives me 1. So our answer here is 1. Nice job. All right, hopefully you checked yourself, fixed yourself, or just walked through that with me. We have our last example and then a few problems I want you to try. Let's do these A and B under example 2 first. We're going to simplify the expression. Guys, I see x, even though we don't know what x is, if it's raised to the 0 power, this is going to equal 1. So negative 5 times 1 gives me negative 5. Let's move over to B. I'm combining my ones that have the same base. So that 9 kind of just hangs out because I can't divide it with anything else. But now negative 3 minus 5 gives me a negative 8, which means I have y to the negative 8. Don't want a negative power, so let's change that. This 9 is going to stay in the numerator where it was, right? It's really over like 1. We keep it where it was. But now we want to move this y to the negative 8 to the denominator. So you'll have 9 over y to the 8th. That's our final answer. What I would like you guys to do, try A, B, and C on your own. Press pause and then press play when you're ready. We'll go over them. All right, let's go through these. First one, we have a negative power, so I want to change that and put it in the denominator. That's all I do. If you have that kind of coefficient there, or number out front, that stays in the numerator. It does not flip to the denominator. This right now has a positive power. It's just 1, so it stays the same. B, I have b to the 0 power, which gives me 1. So I have b to the negative 10th. So let's rewrite that as 1 over b to the 10th. We want to make it positive. So find its reciprocal. Last one, only can combine the bases that are the same. So do 6 minus 9. I get negative 3. Now that 15 is in the denominator, so keep it there. But now I want this term to become positive, so it's going to join that 15 down in the denominator. So this is going to equal 1 over 15x cubed. And that's it. We are done. That is it for chapter 16. That's it for our 8th grade standards for now.